Okay, so have you heard about this Haptiknit thing? It's something about a knitted sleeve that can communicate through touch.
Oh, yeah, I saw something about that.
I was intrigued, so I thought we could do a deep dive today into a research article from Science Robotics.
Okay.
It's called Haptiknit, Distributed Stiffness Knitting for Wearable Haptics.
Sounds pretty technical.
Yeah, a little bit, but we'll unpack it all.
Okay.
We'll uncover how it works and what its potential is and what makes it different from other haptic devices out there.
Okay, yeah, that'd be interesting.
Yeah, so I think what's really cool about this is that it takes such a different approach. We're so used to touch screens and things.
Right.
But Haptiknit actually uses this knitted sleeve with these little actuators embedded in it to create tactile sensations on your skin.
Yeah, it's almost like turning the whole sleeve into a touch screen,
Yeah.
but instead of using your finger to, input commands, it's actually sending sensations to you.
That's pretty wild.
It is.
Yeah.
And it's really trying to solve a fundamental problem with how we experience touch in, the digital world.
Right.
Like right now, most of the haptic feedback we get is limited to, simple vibrations, like when you get a notification on your phone.
Uh-huh.
But touch is so much more nuanced than that.
Yeah.
It's pressure, texture, even emotion. Like think about a hug.
Right.
You wouldn't want that to feel like just a buzz.
No, a vibrating hug would be very strange.
Right.
So that's where Haptiknit comes in.
Exactly. It's designed to be way more expressive and create a wider range of tactile sensations that are, closer to what we actually experience in real life.
So how does it actually work?
Okay.
The article mentioned something called distributed stiffness knitting,
Yeah.
which sounds very technical.
It is a little bit.
Could you break that down for us?
Yeah, so think about like a normal sweater. It's
Okay.
uniformly soft all over, right? Well, with distributed stiffness knitting, they can actually change the stiffness of different sections within the fabric. So imagine like being able to knit a sweater where some parts are as soft as cashmere
Wow.
and other parts are firm, like cardboard.
So they can make parts of the sleeve like hundreds of times stiffer than others.
Yeah,
Just by changing the knitting pattern.
that's exactly right.
That's amazing.
And it's not just the knitting pattern. They also use a special heat-fusible yarn.
Okay.
So during fabrication, they apply heat to specific areas, and that yarn melts and binds the fabric together, which makes it super stiff.
So it's like they're selectively gluing parts of the fabric to create these stiffer sections.
Yeah, that's a good way to think about it.
Okay, so
Yeah.
why is that stiffness so important?
Well, it's all about controlling the force from the actuators.
Okay.
Remember, those are those tiny little devices embedded in the sleeve that actually create the touch sensations.
Right.
So if the whole sleeve was soft, when an actuator inflated, the force would just dissipate everywhere,
Uh-huh.
and you wouldn't feel a distinct sensation.
Right.
You know.
So by having these stiffer sections,
Yeah.
they can kind of direct that force to very specific points on your skin,
Exactly.
creating more precise tactile sensations.
Yeah, it's like having tiny little fingers pushing on your arm.
That's a great analogy.
Like a mini massage therapist built into your sleeve.
I love it.
But instead of needing muscles, it's creating these, very targeted points of pressure.
Okay, so we've got the sleeve, the stiffness variations, and the actuators.
Right.
What about the actuators themselves? What are they made of?
Well, they're actually 3D printed,
Oh, cool.
which is really cool because it lets them create these custom shapes that fit perfectly within the knit fabric.
Okay.
And even though they're made from a soft, flexible material, they're surprisingly strong.
Really?
Each one can generate over 40 newtons of force.
40 newtons.
Yeah,
That seems like a lot for something so small.
it is.
How much is that, like, in real-world terms?
Well, it's like holding a 4-kilogram weight,
Wow,
all from this tiny little actuator nestled within the fabric of your sleeve.
that is impressive.
Yeah.
But wouldn't all that force be uncomfortable?
Well, that's where the knit fabric comes in.
Okay.
It acts as a buffer, distributes the force over a larger area.
So it's combining strength with sensitivity.
Exactly.
That's really clever.
Yeah.
I also noticed the article mentioned something about the system being untethered.
Uh-huh.
Does that mean you don't need to be hooked up to a big machine to make it work?
That's right. They developed this portable pneumatic system they call Airport 1.0,
Okay.
which provides the compressed air needed to inflate the actuators.
Uh-huh.
And it's worn on the upper arm, so you're completely free to move around.
Wow, so no bulky pumps or tanks or anything.
Nope.
That's amazing. They really seem to have thought about making this as wearable and practical as possible.
Absolutely.
Okay, so we've got the sleeve, the actuators, the portable air supply. It's all starting to come together. But how does this actually translate into meaningful haptic feedback? What kind of sensations can Haptiknit actually produce?
Well, to really understand that, we need to dive into their user study. They had 32 participants test out Haptiknit in a bunch of different ways. One of the first things they wanted to know was if people could accurately tell which actuator was being activated.
Oh, so it's like they're trying to create a language of touch.
Exactly.
Like if actuator number 3 is activated, that means turn left or something.
Yeah, exactly.
And how did that go?
Well, the results were fascinating.
Okay.
Participants were able to correctly identify the activated actuator with 69% accuracy.
Wow. So that's way above chance.
It is.
So they're not just feeling random pressure.
Right.
They can actually distinguish between the different actuators.
That's right. And it shows that Haptiknit has the potential to be a really effective tactile display, conveying specific information through touch. But it's not just about simple taps.
Okay.
They also tested whether Haptiknit could simulate more complex sensations, like a stroking motion.
Oh, that's interesting.
Yeah.
So how did they do that?
Well, they created different stroking patterns by varying the timing and duration of each actuator's activation. So some patterns felt more continuous and smooth, while others felt more staccato and broken up.
I'm trying to imagine what that would feel like.
Yeah.
Almost like a finger tracing a pattern on your skin.
Right.
I wonder if they could replicate things like Braille or sign language using those patterns.
That's a great thought.
Yeah.
And it speaks to the potential of Haptiknit to go beyond simple notifications and actually become a tool for communication and accessibility.
For sure.
But one of the most intriguing parts of the study was when they tried to convey emotions through touch using Haptiknit.
Emotions.
Yeah.
That's really pushing the boundaries.
It is.
I'm really curious to hear how that worked.
Well, they focused on 6 basic emotions.
Okay.
Attention, gratitude, happiness, calming love, and sadness.
Okay.
And they designed specific activation patterns for each one.
Wow.
And then participants tried to guess which emotion was being conveyed by the sleeve.
So could people actually tell the difference between like a happy touch and a sad touch?
Well, it turns out that some emotions were easier to convey than others.
Okay.
And we'll get into the details of that in the next segment. But it really highlights how much potential there is for using touch as a whole new language of communication,
Absolutely.
Yeah.
I'm really interested to hear more about that. So
Okay.
we'll pick back up in the next segment.
Great. Welcome back. So remember we left off talking about how the researchers actually tried to convey emotions using Haptiknit?
Yeah. I'm really curious about that.
It's pretty wild.
It is.
So you mentioned that some emotions were easier to communicate than others.
Yeah. What made the difference?
Well, it seems like the location of the touch played a big role,
Okay.
Like some areas of our skin are just more sensitive than others.
Right. Like how a tickle on your foot feels totally different than a tickle on your neck.
Exactly. And it turns out the inner forearm is particularly receptive to touch, probably because, we associate that area with close personal contact.
Okay. So gestures that targeted the inner forearm were more effective.
Yeah. For example, they represented gratitude with a single squeeze on the lower inner forearm.
Interesting.
And not only did participants recognize it easily, they actually rated it as highly authentic,
So it's like our bodies are pre-programmed to understand the language of touch on an emotional level.
Yeah, it's fascinating.
It really is.
It definitely opens up a whole new avenue for research,
Right.
Understanding the interplay between touch location and emotion.
Yeah, and it raises some interesting design challenges for the future. Like if we want to create devices that can communicate a wide range of emotions, we'll need to think about actuator placement very carefully.
Absolutely.
Now, there was one result that really caught my eye.
Okay.
Happiness was recognized accurately, but participants didn't find it very authentic.
Yeah.
What do you think was going on there?
Well, I think that's where the limitations of the current technology kind of come into play.
Okay.
So the happiness gesture was a series of short, sharp indentations across the forearm. Kind of like a staccato rhythm,
Yeah.
So I imagine it felt a bit mechanical and repetitive.
Right, not like the warm, fuzzy feeling we associate with genuine happiness.
Exactly. So even though they understood the pattern, it just didn't feel real.
It makes you think about how subtle and nuanced human touch really is.
Yeah.
It's not just about the location or the pattern, but the pressure, the timing, all those tiny variations that make it feel genuine.
Yeah, that's definitely the next frontier for haptic technology, being able to replicate those subtleties,
Right.
Imagine being able to control not just the intensity of the touch, but the texture, the temperature,
Wow.
everything that makes a human touch so unique.
Okay, I'm getting chills just thinking about that.
Yeah.
But before we get too lost in the future,
Okay.
let's circle back to the stroking experiment. You mentioned it earlier, and I'm curious to learn more about how Haptiknit performed there.
This is where it gets really interesting because it ties into some fascinating neuroscience.
Okay.
So there are these specific nerve fibers in our skin called C-tactile afferents.
Okay.
And they're thought to be responsible for our perception of pleasant touch.
Hmm.
And research suggests that stroking motions within a certain speed range are most enjoyable
Okay.
because they activate these C-tactile efferents.
So it's like there's a sweet spot for stroking speed.
Exactly. But here's the thing.
Okay.
The results of the Haptiknit study didn't quite line up with those findings.
Oh, really?
Yeah, so while participants didn't dislike any of the stroking patterns,
Yeah.
the one they found most enjoyable was actually the fastest and shortest.
That's different from what we'd expect based on the research on C-tactile afferents.
It is.
Why do you think that is?
Well, I think it might have to do with the fact that Haptiknit's actuators are spatially discrete. You know, they create individual points of contact rather than a truly continuous stroke.
Right.
Like a finger moving across your skin.
Yeah.
So the faster patterns, even though they were made up of individual taps, might have felt more blended and therefore more pleasant.
It's like the difference between someone tapping you repeatedly on the shoulder versus gently running their hand down your back.
Exactly.
One is a bunch of separate sensations, while the other feels like a smooth flowing motion.
Precisely. And it's a crucial consideration for haptic design moving forward, you know?
Right.
If we want to truly replicate the nuance of a human touch, we need to think about how to create a more continuous, spatially unified sensation.
So it's not just about having more actuators.
Right.
It's about how they're coordinated and activated to create that seamless experience.
That's right. And there are some limitations with Haptiknit's current control system that kind of prevent this.
Okay.
So right now it's an open loop system, which means the actuators can only be either on or off. There's no way to finely control the pressure or create more gradual transitions between those touch states.
So it's like a light switch.
Yeah.
It's either on or off, there's no dimmer.
Exactly. But the researchers acknowledge that a closed-loop system with more precise pressure control would be a major advancement.
Right.
Imagine being able to adjust the pressure in real time.
Yeah.
Just like we do with our hands when we interact with the world.
Wow.
That would take Haptiknit to a whole new level.
That would be incredible, being able to feel the subtle variations in a handshake or the gentle pressure of someone holding your hand. You know, that's the kind of detail that could really blur the lines between digital touch and human touch.
I agree, and that's what makes this research so exciting.
Yeah.
It's not just about a cool new gadget, you know. It's a window into the future of touch and a roadmap for how we can keep refining and enhancing these experiences.
I think this really drives home the point that we're just at the beginning of understanding the possibilities of touch-based communication.
Absolutely.
As we learn more about how our brains process touch, and as our technology gets more sophisticated, who knows what we'll be able to achieve.
Absolutely. I believe we're on the cusp of a whole new era where touch becomes an integral part of how we interact with technology, with ourselves, with each other. We're talking about devices that can deepen our emotional connections, improve accessibility, and ultimately create a more human-centered digital world.
This has been such an eye-opening deep dive.
It has.
We've learned how Haptiknit works, explored its capabilities, and uncovered some of the big questions it raises for the future.
Right.
But we're not finished yet.
Okay.
When we come back, we'll step back and discuss some of the broader implications of this research.
Sounds good.
Get ready for a thought-provoking conversation about how Haptiknit could change the way we connect with the world around us. Welcome back. We've spent this whole episode unpacking Haptiknit. From its clever engineering to the mind-blowing user study results, you know.
It really does make you think.
It does.
About, you know, what this all means for the future, how it could change the way we interact with the digital world.
Yes, it's such a huge shift. You know, you're so used to screens and keyboards and even voice commands now.
Yeah.
But bringing touch into the equation just opens up a whole new dimension.
Touch is our most fundamental sense, right?
Yeah.
It's how we experience intimacy, connection, comfort, you know?
Yeah.
What if our devices could communicate with us in the same way? Using subtle tactile cues to, you know, share information or even provide emotional support.
It's almost like a sixth sense.
It is.
But wouldn't that require a whole new language of touch?
Yeah.
How do we even begin to teach our devices to speak it, and how do we learn to understand it?
That's a big challenge, and it's not just about translating existing symbols into touch patterns. We need to think about how different types of touch evoke different emotions and responses.
Yeah.
A firm squeeze might convey urgency.
While a gentle caress could signal reassurance.
So it's like we're designing a whole new vocabulary for human-machine interaction.
Exactly. And just like any language, it'll need to evolve and adapt over time as we learn what works and what doesn't.
Absolutely. And as we develop this new language, we really need to consider the ethical implications, too.
Oh, for sure.
Touch is so personal, It can trigger really strong emotions, even influence our behavior.
Right.
So we need to be very mindful about how this technology is used and designed.
Absolutely. It's a reminder that every technological advancement comes with its own set of challenges.
Right.
But, even with those challenges in mind, I'm still optimistic about the future that Haptiknit represents.
Me too.
It's a testament to human ingenuity,
Yeah.
our desire to connect in new and meaningful ways.
It really highlights how technology isn't just about faster processors or sleeker designs.
Right.
It's about creating deeper, more human-centered experiences. Precisely, Haptiknit isn't just a cool gadget. It's a powerful symbol of what's possible when we start to think differently about how we interact with technology.
So as we wrap up this deep dive, what's the one thing you hope our listener walks away with?
I hope they see Haptiknit as an invitation,
Okay.
to imagine a future where technology becomes more intuitive, more empathetic, more in tune with our human needs.
That's beautiful.
It's a reminder that we're not just users of technology, we're also its creators, and we have the power to shape its development in ways that benefit all of us.
So well said. And for our listener, here's a final thought to ponder.
Okay.
If Haptiknit can already convey emotions and complex information through touch, what other possibilities might we unlock as this technology evolves? Could it become a new form of communication, a way to express what words sometimes can't?
That's a great question.
The future of touch is ripe with possibility, and we can't wait to see what unfolds. Thanks for joining us on this deep dive.